And here I am. Good morning. Good morning, everyone. Are you there? Can you hear me? Let me know if everything works. Oh, good morning. Good morning. Good morning. Perfect. Perfect. Good morning. Good morning to all of you. Very good. Okay, so before we start with new unbelievable things in Inventor, do you have things that you want to ask me? Problems, doubts, something about final projects and stuff like this? Is there anything that you want to ask me? Feel free to ask me. And today I will show you a little bit of, not a little bit, I will show you how to use, for example, how to make simple renderings inside Inventor. Then there are other functions that we still need to explore into the 3D modeling area. But if you have questions, I would like to hear from you. Doubts, whatever. If you have. It looks like you have not. So there can be just two possible scenarios. You have no doubts, or you just fell asleep again because you're not writing me anything. Interesting. Okay, so these can be closed. Okay, this works. So let me simply check my video. Perfect. It works. So we can continue. Okay, so today we have to see several things that are that we have basically skipped in previous lessons. First of all, I need to show you some tools into 3D modeling that we need still to explore. The reason why I've skipped it is that because they are, first of all, slightly less useful. Not useful, I mean, less used in general. And also because they are a little bit tricky in order to properly work. But I will try to do my best to show them. Then today I will show you how to start making renderings in Inventor. Another thing that I would like to show you today is how 3D models from Inventor instead can be used inside 3ds Max to make presentations of your works. Okay? So, if you have no doubts and nothing that you want to ask, I will start. So, let's start with Inventor tools. that we need to learn. Let me just resize this a little bit so that I can have always an eye on the chat, like that. Perfect. So at least if a message pops up, I will see it. Okay, so let's see this tool here first. That is a little bit complex, but not impossible, I will say. The tool that I want to show you is called Sweep. And basically, what you can do when you use Sweep tool in Inventor is that you can draw a path, and the path can be open or closed, it doesn't matter, but it has to be one sketch, and you need to draw a second sketch that should be a closed sketch if you want to make a solid object, or it can be open, but in that case the result will be a surface kind of object. Then these two sketches will be combined together so that basically if you have a path that is like this, and if you have a sketch, let's say, that is like that, your 3D model will be basically the extrusion, we can call it, the extrusion of your sketch along the path. This is something that we have also studied in 3ds Max. In 3ds Max it was called loft. That is also interesting because loft, there is also loft in Inventor, but it works in a completely different way. And so, which is the only tricky part of using Sweep in Inventor, and why I postponed explaining this? The only tricky part is that when you draw sketches, there are preliminary sketches that you are about to use inside Sweep. What happens is that you can't make sketches, so both sketches, the path and the section, you can make them on the same plane, because if, let's say, if I use this plane and I draw the path like this, and I also draw a circle on the same plane, Inventor will refuse to use the combination of these two sketches, so it is not as simple as it works in 3ds Max. Instead, what Inventor wants is that I need to create sketches in two different planes, and the more perpendicular these two planes are, the better and the more precise will be the result. So, if first I make this plane, and then I draw my profile here, then yes, then Inventor will combine the profile and the path, and it will give me my solid, beautiful sweep result. So, let's see how it works immediately. So, first of all, I will start very easy, and I will use two available planes. So I will draw the sketch on the XZ plane, and this for me will be the path sketch. And because I want also to be to make it simple at the beginning, when you use a plane and you see these two black lines here, I will just write. Basically, this is the projection of the front plane, as well as this is the projection of the right plane. So, basically, when I want to make a sweep, what I have is that I already have 3 perpendicular planes. So what I'm going to do is simply, I will make, let's make it as a spline, just because it looks better. I will make my spline starting from this point, so that my starting point, this one, is also starting from the projection of my front plane, and you will see how handy this becomes in a second. So let me finish the path. I will click OK here to finish my spline. No, I like it, so let's click finish. So this is going to be the path to follow. And what I will do next is, this has been made onto the top plane. In order to make the section, I have to use a perpendicular plane. Technically, I could select both right and front, but I want to be a little bit more precise, and I will select the front. I will click sketch, and I will draw a closed profile. Closed profile could be whatever, and I will just make a rectangle, and I will click finish. So look what I have now. I have these 2 sketches. This is the path, and this is the section that I'm going to use for my sweep. Okay? Till here, let me check if you are following me. So till here, does it work? Can you do steps that I've done till now or not? Give me a feedback before I go on. Perfect! Thank you so much. Great! Believable. So now, check this, because this would be fantastic. I have these 2 sketches. I click sweep, and what is great is that Inventor immediately finds that one is a open path and one is a closed one. So without even telling the software which one should be the path and which one should be the section, we have immediately our unbelievable sweep result. And of course this is easier way to do it. Later on I will show you also that you can, let's say if you have 2 closed shapes, you can also use sweep, and you can select manually which one will be the profile, which one will be the path. Okay, so let's start easy, and let's see what we can do when we have sweep. First of all, what we have done is basically we have extruded our shape along the path, and in each point along the path our shape is going perpendicular to the path itself. It would be a little bit more complex because it is perpendicular to the tangent whatsoever, but it goes perpendicular. There is another way that you can use sweep. In this case, because we have this curve, it probably won't work. That is, first thing we can change can be, we can choose to follow the path. That is a more natural way to create a solid with sweep. Or we could select parallel, and basically the section remains parallel to its starting orientation, and it goes along the path but without rotating its orientation. So we will have this weird final result. In this way, my rectangle goes parallel to itself, no matter how the path changes. So, first thing that we can do is changing the orientation of the path that changes along the curve or not by clicking parallel. When we keep the option path, we also have these two beautiful options. One is called taper and one is called twist. What they do is very simple. Taper is an angle. So if I type, I don't know, 10, and that is too much, let's say 2 degrees, still too much, 1, no, wait, let me do it again, sorry, okay, let's say 0.25 degrees, because probably my shape is very small, let's say 0.5, exactly. So what happens is that basically along the path I will see that there is a deviation of the path from this profile from the path, and then I will show you with a simple 0.7 is too much, 0.6. So you can see that basically my shape starts thin and it slightly goes bigger. Later I will show you another example. We can go minus, and instead of becoming larger all along the path, instead if I click minus the degree, my shape goes thinner to the end. Let's say if we can go more thin, yes, like minus 1 degree, minus, no, this is too much, minus 1.5 degrees, no, it doesn't like it, minus 1.25. And you will see that the more my section goes along the path, the thinner the shape becomes. And if you remember 3ds Max, believe it or not, this is something that you have seen in 3ds Max when we have explained the homework about the octopus when we were making tentacles. So this is taper. But there is another interesting parameter that we have when we leave path as a orientation, that is twist. So what twist does is Basically, right now, our profile is going along the path by keeping a perpendicular orientation, but the top of my rectangle is always the top of my sweep object. Left remains left, right is right, below is below. What we can do here instead is we can tell that from the beginning till the end, we maybe want our profile to rotate along the path. So, let's say if I write an angle that is 90, what happens is simply that along the path, my profile does 90 degrees of rotation, so that it starts horizontal at the beginning, it will finish vertical at the end. But this will make like a quarter of a complete loop. We can write whatever angle. Let's say if I write 360, what happens is that my rectangle along the path will make a 360 degrees rotation till it finishes the path. And if I want more rotations, let's say I want 1 and 2 rotations all along the path, just increase this number, let's say 720. That is 2 times 360. So my profile will make 1 and 2 complete rotations before reaching the end of the path. Okay? And then only when I click OK, my solid will be created, and I've made this. So this is basically a rectangle that goes all along a weird looking path, and while it follows the path, it is also making a rotations of 720 degrees. Okay? If we don't need it, just double click on the function and put twist back to 0. Click OK, and this is our simple sweep. Okay? Till here? Does it work? Because then I want to show you a few more examples of things that we can do with sweep. Very nice. Okay, so let's see something. Sometimes you may experience, like I was doing before, that you have no preview while you are doing your loft. And when this happens when the path and the profile that you draw are not compatible. And in general, being not compatible, I will just make a quick sketch. No, let's change the orientation before. But you can see this. You can see that I have made on purpose a very long, curvy, nice path, and I have made a small profile. I mean, this is simply because I have already tried multiple times this tool. But sometimes you don't see any 3D solid. And in general, if this happens, is because if you have made, let's say, this path, and if your profile, so the one that have to go along the path, is, let's say, something that is big like that, what happens is that during the loft, this section might be so big that it will have all these self-intersection areas. If this happens, basically Inventor won't create any solid out of the combination of the profile and the path. So if you experience issues like you try to use sweep and it doesn't work, remember that 99% of the time is that simply because or curves of your path are too tight, or section that is called profile of your sweep is too big. Okay, but 99% is always this. So let's try another thing that is, let's see, because sometimes it may happen, and delete this one. Yes, delete everything. Let's see what happens if I want to make a loft, but I want to use, sweep, but I want to use two closed shapes. This is possible too. It works same exact way. Just because I'm lazy, I will use a circle as path, and I'm drawing it onto the top plane, but I want to be less precise now. And look, instead of drawing my rectangle exactly on the beginning of the path, I will just choose a vertical plane. I will make another sketch, but I will draw without any care. I will draw a rectangle here. So it is not following exactly my path, but it's okay. Let's see what happens. Because technically I still have everything that is needed from loft in order to create a 3D solid. I have a closed shape that I want to use as profile. I have another shape that I want to use as a path, and I also have that the path and the profile are drawn in two perpendicular planes. So technically I am good to go. Let's see what happens. So first of all, I click sweep, and you can see that because these two shapes are both closed, Inventor won't recognize immediately which one is the profile, which one is the path. So I have to manually select them. So first I click profile button, and I click path, then I click profile, and you will see this. Basically, even if my path is placed somewhere else, the section that leads the sweep operation is the profile and not the path. So technically, wherever is the profile is where I'm going to build my three-dimensional object, and basically Inventor will move a copy of my path sketches into the center of my profile section. everything else is still the same. Even if this is closed, for example, look, I could do the twist. I could make this beautiful, weird looking thing. That is, I could twist my object 360 degrees while it is making the curve. But you can see that while my previous example was a lot more linear, by having things drawn without any care, results may be a little bit wrong. And an example is this one. So the twist. We all think that the circle remains where it is while it is twisting, while it is not. See this weird result. Okay? This is why, first of all, let me tell you the shape, let me create this shape. Yes. And then I will tell you what is written there. Let me tell you that this shape is phenomenal, even if it is 100% wrong. Wow! I mean, it's great. But why this is wrong, and what was the error message that Inventor says? Inventor says that, look, it is true that you have made a path, a profile, but these two shapes are not intersecting each other, so the result may be inaccurate. And this is exactly what is happening right now. So instead of having a simple rectangle running all the way along a circle and maybe twisting along the circle, we have this weird result simply because rectangle is here, circle is there, so the rectangle basically goes like this around the circle. And this is why when we use sweep, we should be a lot more precise than any other tool that we use inside Inventor. And this is also why in general I wait before explaining it, because it requires a lot more precision. So what it means is that when I create loft, if I want to be sure that the result is accurate, my rectangle shouldn't be there. But my rectangle, and also see what I do. I want to exactly draw these lines so that I can even choose exactly where I want to move my rectangle, because I want to move it from, and I will click base point, from this point here, I would like to move it here. And then I will delete this. In this way, I start by placing my section in a more correct position, so that when I will use sweep, I click the path and I select this one. I click the profile and I select this one. And I have no surprises. If I click twist now, you can see that even more, let's say 720, you can see that the result is exactly what we need to expect. That is our rectangle rotating around the circle, making a twist around circular path, so everything works as it should work. Okay? Till here? Because I want to show you one last thing about sweep, and then I will show you another tool before showing a couple of unbelievable things about renderings. So till here, is it fine? Let me know. Yes, perfect. Excellent. Great. Okay, so let's see this last thing. That is, let's say I want to make something very complex, and I want to use a path that is going to be a spline that is less. So let me delete this one. Yes, delete everything. So, let's say I have a spline, whatever, this one. And I don't even start from this point because it would be too easy. So, I follow my sketches, my ideas, and this is the path that I want to use for sweep. So now I have no more simple references to create a perpendicular, a section on a perpendicular plane. So how should I do in order to be sure that my sweep will work? This is a case when we need to be very technical, and before creating a second shape that is going to be used as profile, we need to create an additional plane. So what we need to do is basically we need to use this feature. That is, we have to make a plane. We have to make a plane, this one, normal to axis through a point. So it takes 1 hour to tell the name, but basically this is the point where we, no, come on. 1 second. Was this? Or it is? Yeah. Or this one. 1 more second. Ah, come on. Normal to curve. Sorry. It's normal to curve, not normal to axis. My bad. So in the final video that I will edit, I will cut this part so that it looks like everything works. So I will cut it from here till here. So I was saying we need to use this function called make a plane normal to curve at a point. And we just click if we want to make our profile from here or from there. I will use this point, and boom! By clicking the spline, after clicking the vertex where we want our plane, believe it or not, Inventor has created that perfect plane that we need to create our sketch. So I will select this plane and I will make my sketch. let's say I want to create it. No. I want to make lines this time to have something with corners. Exactly. Perfect. So now what I have is, I have this beautiful sketch that starts exactly with the right orientation and with the right position that I want in order to follow this path. So I click sweep, and again, just because my objects are one open and one closed shape, Inventor finds immediately the combination of these two objects working. I will click OK, and this is my final result, where the profile follows the sketch that I have made, starting from that extremely precise plane. And if I don't want to see it, I will just select the plane from my model browser. I will right click on it and I will uncheck visibility to hide it. Okay? Does it work? Let me know. Or if not, I can make another example. I mean, it's not a problem. Okay. Yes. Should be yes. Okay. Perfect. I mean, don't be shy. If you want another example, just ask me. I mean, it's not the end of the world. Chat is muted right now. I know that you want me to show you again that plane feature, but no one is brave enough to ask me. Let's see. And if you won't ask me, I won't do it. Believe it. So, while I'm waiting your chat, I will do it again. I mean, because I'm too good. So, see this. Let's draw another thing, because if not, I will always do the same. So, let's say I make this path. Because sweep is not always to make nice round things, but sometimes you can also use sharp shapes. But again, I have drawn this path without really any care, so it is not starting from any particular direction, any particular vertex. So how can I be sure that the profile that I will create is perpendicular to my plane, to my path, and not just random? First of all, I mean, only if you don't believe me, but see this. If you make the path and the profile into the same plane, look, this won't work. And it clearly says that the path and does intersect the profile, and there is no way to make a 3D solid with sweep by using the path and the profile from the same plane. Okay? So this is first. But what I wanted to do is basically this. I want to make a new plane. I will make a plane normal. Normal means perpendicular to a curve at a certain point. So I can make it here. But what is interesting is that, look, I have made multiple vertices. So let's see this. I can make my point here, and I then can choose which must be the direction that I use as a perpendicular. It will be the same. Let's choose this one. And you will also see why I may be interested in starting my profile not from the beginning or the end of the path, but from somewhere along the path. Look, I mean, this can be interesting as well. Okay, so this is my plane. I will select it, and I will make the sketch that is going to be my profile. And I will do it, I mean, something very simple. Something like this. Okay. And finish the sketch. So I have my profile perpendicular to the path, but this is not at the end or at the beginning of my path. It is somewhere along the path. So let's see. I click sweep. I have to select the path. It works, so it gives me an unbelievable, nice, sharp looking result. So why I may want to use this particular trick to use sweep? So why not making it at the beginning or at the end? The only thing, honestly, that changes is only that if you use taper or twist, taper and twist start their effect from where the profile is. So what it means is that if your profile is at the end or at the beginning, basically, what happens is that from that you see your section remaining the same at the beginning, and then you see the section slightly decreasing or slightly increasing its shape. But if your profile is placed in the middle of the path, if you use, let's say, taper, let's see if it works. 2 degrees? No, too much. 1. Oh, I'm so unlucky. 0.5. Not even. 0.25. 0. Nothing works. No, I'm so sad. 0.1. No, that's okay. So forget about it. I will show you in a second. Look. So let me delete, sorry. Because probably it's a little bit too edgy. But let me make another sketch. Let's see if it works with a circle. So I click sweep, path. Let's see. Please work. No. So sorry. It should work. Nothing. It's okay. So don't do it. It's very simple. Sweep this. Okay. And it works. And you have this. So doesn't matter where the plane is, but just has to be a plane that is perpendicular to your path. Okay? Because if sweep is fine, I would like to explain another feature. So let me know if this is fine first. Is sweep clear? Yes, please. Tell me. Oh, great. So let's see this other slightly complex feature that is called coil. And take care, because you can see two slightly similar buttons here into your Inventor interface. There are these two. Look, there is a button here. This is called coil. And there is a button here that is called threads, I think, if I remember. Yes. It's called thread. Oops. Oh no, close it. So they look similar while they are not. And we will basically, we won't even use thread, this one. This is just to tell CNC machines if an object must be managed as a bolt or a screw, but it's not something that will affect in any case your 3D model. So we won't use thread. We need instead to explain what coil is and how it works, because it looks simple, but technically it is a little bit tough to work. So it's a little bit tricky, I would say. So what coil does is basically it allows you to make something that looks like a sweep final result. But coil has a parametric way to use sweep, that is, you can create a profile, and the trick is inside same sketch of your profile you must draw an axis, and then what coil does is it uses your axis as a center of rotation, so at the same time your profile is extruded with a circular motion if we see this process from the top. But at the same time, the extrusion goes up. So at the end, you give your profile a spiral extrusion by using that line as a axis of your spiral. So let's see how it works and things that you can do with coil, because they will be pretty interesting. So let's see this first. Let's create a very basic sketch where let's orient Inventor to the right way. So let's make it something very basic. Example number 1. Look, I make a circle and I also want to make a circle with dimensions that I can remember, so I will make it 10 millimeters as diameter. Then I will draw this line, and just for a little bit of precision I will keep it vertical, but I will select this line and I will click that this line must be a center line, so that Inventor counts this not as part of my 3D solid but as an axis. And these two elements, look, are both made into the same sketch this time, and this is the trick. So now I can finish the sketch, and I have this. I have a circle with this vertical axis here. So what I will do now is I will click Coil. Inventor finds my only closed shape, so the profile doesn't need to be selected. Then I have to click this arrow that is called Axis, and I will select the axis that I have made into the same sketch. And now the fun part begins, because now you can see what Coil starts doing. That is, now I have that my circle is about to follow the axis by making one rotation. So as I was saying into the sketch, look, if I see it from the top, the profile is making a rotation. But at the same time, if I see it from the front, my circle is going up, so this is becoming a spiral. And this movement is entirely parametric, so I need to go, after selecting these two elements that are profile and axis, I have to go to Coil Size, and I have these two main numbers. The reason why they are called pitch and revolution is because technically coil is made to create gears, and gears have these two names to describe. Pitch is basically the height of each loop, so it means that from first 360 degrees loop till next one there will be 10 millimeters. That is this, and you can change this one, and by changing these you will see that this spiral will be taller or shorter. So if I make 50 millimeters, you will see this. Okay, 20 millimeters or 10 millimeters, and you will also understand why I made the circle that is 10, because I want all my circles to perfectly touch. And then instead of having the rotation described with degrees, this is revolution means how many turns my coil is going to do. So 1 means 1 complete rotation of 360 degrees. If I make 2, it will make 2 rotations. If I make 1.5, it will make 360 plus 180. So let's say I want 10 rotations, and my spiral will make 10 complete loops. When I will click OK, failed. Why? No, come on. Axis. This one. Let's say revolution 4. This is unfair, honestly, because there is no reason why. I mean, thanks the specified inputs self-intersecting. Okay, let's make 15. Nah, I don't know, it was too small. Okay, so this is what coil does. Okay, and I will show you again, because what we are doing is not only we are technically extruding a shape along a spiral path, but we are creating a solid in this way. So let's do it again. This time I will create something before. So look, if I make a cylinder before, like this, and I will make it 20 millimeters tall. Okay? Then, see this. I will go to a vertical plane. I will make a sketch, and I will make this particular sketch. Look, from the center going up, I will make my axis, and I will do this phenomenal thing. That is, I will draw whatever shape, let's say 5 millimeters. Then it goes inside. And if you want to see the shape inside, just go to View, and instead of using the visual style shaded with edges, I will use wireframe. So I can see that I need to close this sketch here. Perfect. And I finished the sketch. So look what I have. I have a cylinder that I have created before. Then I have this closed section, and in the same sketch I have drawn these axes. So I can click coil. I will pick the axis, and first of all, you can see that in my coil operations, the spiral is always going up. That is where I really want. But if this is not happening in your cases, first of all, you can, after clicking Access, you can click this button here. And you can flip the direction of where coil is going. Also, if you want, you can change if you want a clockwise or anti-clockwise rotation by clicking these two buttons here. But my main interest now is not really the coil itself, because we can change parameters, we can do whatever we want. But what is interesting now is that because I'm using coil as second solid, I can see that now I am also able to choose if I want to use join or if I want to use cut in order to create my solid object. So let's say I click cut, that is more interesting. I click OK, and let's go back to shaded with edges. So my coil has instead cut that part from the cylinder. Okay, so instead of creating something like a spring looking element, I have removed that part from the cylinder. So I can double click on coil, because if I change pitch size, let's say 10, let's see if it works. Click OK. So it becomes shorter, so it makes more turns in that space. This is the result that I get. Okay? Yes? No? Maybe? Perfect. So now, there will be few more things that I would like to explain into 3D models, but we will explain them another day, because now I want to show this. You may have projects to start. You have to start presenting projects to some teachers, and maybe you want, till now we have explored Inventor mainly in order to build 3D objects, and we haven't finished it yet. There are a lot more things that we have to study. But there is an interesting thing in Inventor that is, without going crazy, without exporting, not explaining, without exporting these 3D models to other softwares, you need to know that you can easily make quick renders directly in Inventor, so that you can present them to your teachers. And the only thing is that you need to find where these tools are, and they are not that simple. So, see this. First of all, so we can skip inspect. Yes, I will show this another day. Let's start by going to tools. First thing first is that in Inventor, when you go to tools, there is a part that is called material and appearance. This works in this simple way. That is, you click material and you select material from water. This is very nice. Say titanium, steel. And what happens is that by clicking materials from here, you do something that is a little bit more interesting than just applying materials into 3ds Max, because as you can see, first of all, this library is called Inventor Material Library. It is not that big, it is not that rich of nice looking material. But why? Simply because these materials, oh, it is concrete, and probably my object is very small. This is why it is looking with this horrible texture. But what is interesting is that all these materials have not only the look of the material itself, but they also have physical properties of that material. So it is a little bit beyond the appearance of your object. And what you do by giving a material, you prepare basically your object also for more complex operations like stress analysis, force analysis. So you can see what happens if you try to push your object, if it is made in metal, if it is made in plastic or glass and stuff like this. So giving a material, let's say ABS plastic, it is a little bit more than just changing the color. While if you double click on the material, it is still possible to change parameters of the material itself. So I can also go to appearance of my material, where I technically shouldn't touch the tab that is called physical tab, because in here is where those nice guys at Autodesk have already placed all mechanical and physical parameters of material behavior, while I can change the appearance, because this material is called plastic, okay? But why plastic must be white? So if I want plastic with another color, I just double click on the material and then I can change the color. And I will have red plastic, for example. Okay. And I can change if I want a picture. So next to the color, I can click image and I can select images or a pattern like this. Okay, maybe this would be too big. 1 inch. I don't know also why I started in inches. It's okay. And if I make this bigger, I'm going to change my materials. So I click OK. I will appearance in the same document. Yes. Double click. OK. And I will change this one. So you can change materials. Let's say I like gold. Okay, so select, add, wait a second, gold. Exactly. Oh, why is freezing? Wait a second. Okay. Material. No. Why it is frozen? Okay. And now I have it applied. Phew. Okay, it was frozen for a second. Phew, it works now. So, first of all, you can change the material. You can also change, but this won't change physical parameters. You can also change instead the appearance. That looks the same, while appearance works face by face. So it is something that will affect only the color of faces. Okay, while material is applied to the entire object, if you click appearance, let's say something this yellow. Okay, with appearance you can select only faces of your object, and you can quickly give this one, this. Okay. Yes. Add to document first and then apply it. Perfect. So with appearance, you can instead change just faces of your object in a very, very quick way. And this is to change the look of an object. But last thing that we need to do, and I hope it works while I'm streaming, not that sure, is finally we need to see how we can create renderings from Inventor without using any external software. Okay? So, to make this happening, what we have to do is this. Look. We have to go to environments. And this is first thing that sounds weird. After going to environments, we need to open this additional environment that is called Inventor Studio. And I click it. Okay, and you see basically a new tab appearing in your toolbars that is called Render. This particular environment, today I will show you with a part. Maybe next week, if I create previously a complex model, I can also show you that Inventor Studio is available also when you make an assembly. And this is why in this Inventor Studio you have something called render animation. Because technically, if you have an assembly, you can basically create a simulation of how all parts of your assembly are mounted together, and instead of rendering these as different pictures, you can really make an animation where all of your parts are attached together or detached, and you see the process of doing this. But let's start with easy stuff. That is, when you are into environments and you open the environment called Inventor Studio, you start by having these new tools. In here, without going too crazy, what you have to do will be this. Look, most important thing is that you can click this starting button that is called Studio Lighting Style. And we need to know what this means. In softwares like 3ds Max, easier way to create environments and renderings is to build the environment, build light sources, place them and change them as we want. In a software like Inventor that is not meant to create renderings, creating lights is possible because there is also the possibility to place lights, but believe it, it takes forever. While in Inventor there is this light simulation that is a new kind of thing, but I mean, I will show you. By opening Studio Lighting Styles, you will work with something that is called IBL. IBL means image based lighting So what you do is, by using not physical and software made light sources, but by browsing these pictures, there are 360 degrees panoramic images with a technology that is called HDRI, so high dynamic range images. What you create is that you can take informations of lights from these images. Okay? And in order to choose the one that you really want to use, let's use this one, Old Warehouse. You go to Studio Lighting, you select the one that you want, or if you download other pictures, and they must be in this very complex format, so just Google it. There has to be a studio style file. You can even import new file. But if you want to use this picture, you select it, you right click on it, and you click active. Okay? In your viewport, let's delete this, you will start viewing that things are slightly changing. So look, if I select another one, say this one, right click, active, the IBL environment as it was written changes, and it changes the way that my object receives illumination. Okay? You can choose this one or this one. Okay? You just select the one that you want to use. Let's say, no, there is another one that is beautiful. This one, Stuttgart Courtyard, active. This would be a lot brighter with this kind of bright sunlight. And you can change in here the exposure to make it more bright or less bright. You can change the scale of the picture. And in general, you should keep it as it is. But most of the time, I will show you this because Inventor parts are small. Sometimes scaling the background can be an interesting thing to do. But let's see this. So, look, I have, let's say, save, done. So, once that I have my light done, what I have to do is very simple. And I hope it works while I'm streaming, because yesterday 3ds Max was giving me a lot of issues. But if I want now, I can click render. I have to choose a couple of things, like which camera I want to use, and it's fine, I want to use this camera. The lighting is the one that I've selected. The output, so if I want to save as an image, and the renderer parameters, and I will keep these by iteration, high, render. Let's see if it works. Yes, it works even while it is streaming. And you can see that here my material was looking red, but if you remember, I have used a checker pattern, so it is appearing in the rendering only. It has made 26, 27. We are almost there. Boom! And I have made my first unbelievable Inventor rendering. If I forgot, let's say, to put the render output, it's not a big deal, because once that I render, even here there is the save render image, and I can save my image even afterward, and I can save it as a PNG, bitmap, GIF, TIFF, and whatsoever. Okay? But let me show you a couple of more things that are, first of all, the projection. So, if we are using the viewport, that is easier way to make renderings. We need to know that this will be a isometric projection. But if we want, what we can do is, before making the rendering, we can simply right-click over our view cube, and we can change from orthographic, we can change our viewport to perspective, so that it will be a bit more natural looking when we have complex models. So we will see vanishing points, and looks a little bit better. So if I zoom in, I will see it like that. And this is first thing. So we can set our viewport to perspective, or we can add cameras. Okay? And cameras are working in a very weird way. That is, we need to select a face that will give us the axis of our camera. Okay? And then we have to move the camera along these axes. So it's not super user-friendly as a process, but it's okay. Then we can change the field of view, and then we can click OK. In this way, we have the possibility to explore our model as we want, but then we can go to the camera, and we can click Set View to Camera. This is exactly what our camera is viewing. So if we want to change it, move it, change parameters and so on, we can be extremely sure about what our camera is going to view. And last beautiful thing that I want to show you, when you use renderings from Inventor, something that will make your renderings a little bit more realistic is this. When I click render and I select my camera, my background, my lighting style, you can see that when I render, even if I am using something called IBL, so I'm using an image to create lights, the background is a little bit anonymous, I would say. It is very boring, and it is not showing that beautiful image that I have selected to create light also. And this is a shame, because if I am able to use that picture as a background, it would be perfect to make more realistic renderings. And what is interesting is that you can use the image not only as lighting, but also as background, just by doing this. Look. When you go to your studio lighting styles, so not only you can choose which image is going to create light, changing the exposure, rotation, and so on. But when you select the image that you need for your light into studio lighting style, there is this interesting tiny check button that is called display scene image. And look at that. So not only your image becomes the one that allows you to create light, but it also becomes the background of your image. And this is why sometimes it's interesting to use scale the picture, because you can quickly adjust the proportion of your background image in order to match a little bit better. So I will click save. Done. It matches better the interaction between your object and the picture itself. Okay? So set view to camera. Perfect. So now see this unbelievable result. I have a picture as a background, and it is also my light source. I render my image, click OK, the camera is fine, lighting style is fine, click render, boom! It will take just a few seconds more, but now you have your rendering quickly made in Inventor with a light that comes from the picture and the picture itself used as a background. Okay? Yes? No? Probably? Of course, you can make bigger resolutions. When you go into render image in here, you can increase the size if you need to have more resolution. You can change these by using presets, or you can just type images that you want, and if you type a certain value and you see this white rectangle appearing, this is called safe frame. So this is telling that Inventor will render only this part in here. For example, my object is vertical, so I can probably use this resolution that is vertical rather than horizontal. Okay, so this will be more on the vertical than horizontal, so that I've used full HD but vertical, because probably I can put now this in my Instagram feed as my first beautiful Inventor rendering. Okay, till here? Yes? No? Maybe? Does it work for all of you or not? It looks like the answer is not, because there is chat is muted. Oh, but look at my beautiful rendering. If I was doing this, let's say, I would just Photoshop a little bit here to put a shadow, and it would be a masterpiece. Oops, where is the chat? Here. Okay, we have 3 yes, we have few silences. Because you have to know that I want to explain this today, because a student that is an Inventor student that is a little bit too silent today had problems in making ray trace with his computer, and I'm curious if now everything works or not. Okay, but at least I have first 3 yes, thumbs up. So in the meantime, because I don't want to explain anything new now, but just let me remember, have I explained already what to do as a final project for Inventor or not? Have I explained your final project before the break? Is it possible? Let me remember, cause I honestly don't remember. Give me a sign. Okay. Yes. Okay. So, and is it possible that I have explained that you have to make like a mood board and uploading to the server or not? Because I would like to see what you want to develop in Inventor, so that I can basically understand what is more interesting to be explained during next classes, according also to which are your ideas for your final projects. So if you haven't done it yet, be so nice. During this week, make a simple 3 2 pages of presentation, 2-3 slides in PDF, in PowerPoint, as a JPEG, as you want, of the final project that you want to develop for this class. And according to what I see from your final project ideas, I will start making next classes a bit more oriented to help you in developing your projects. Okay? Is that clear? Let me see. Yes, no, tell me something, please. Is the video working? Yes. Yes. Okay. Perfect. I should print this chat. It's very nice. Look, it is good morning, good morning, good morning, ciao, good morning. Yes, 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 yep, clear. Very nice. I should print it. I mean, it is very nice. If words are for free. I mean, if you want, you can type even more words. I mean, they want. Anyway, if everything is clear, I want to check your final project presentation during this week. So be so nice to upload them into the same folder where you upload your homeworks. And with this being said, for today, I will stop here. Okay? And I will just wait a little bit of delay of the chat to say bye to all of you, and we will see next week, Thursday. Okay? Let's see. Okay, so it has been amazing. Perfect. So, see you guys next time. And if you have problems, send me emails as usual, and I will try to help you as much as I can. Okay? Bye, everyone. See you next week.